In this example, we're going to compute present value using compound interest. And by that, we mean we're going to figure out how much we need to deposit initially to achieve a certain goal. What do I have to do now in the present to end up with this delightfully large sum of money, $179,646.24. So let's look at the language. What lump sum should be deposited? So lump sum just means kind of like a wad of cash that you're going to deposit one time. That's compound interest. Set it and forget it. So I want to know what P is, but I know R is 9%. I know that I'm doing it every 4 months, so that tells me about N. And I know what I want to end up with. That's A. I'm going to do it in 28 years. Right now, N is a little bit of a mystery. It's not 4, by the way, in case you were thinking it's just 4. It's not. I do know I'm using compound interest, so there's my formula. And let's see if we can figure out what are the values. So we've got A, P, I don't know, R, 9%, convert it to a decimal. N is 3. So if we do something every 4 months, then that's going to be 3 times a year. So 4, 8, 12. So that's 3 times a year. I'm going to do this compounding. T is 28 years. So I'm going to plug all those values into my formula. And of course, PEMDAS. So let's go ahead and take that 0.09 divided by 3. I'm going to add 1 to it to kind of finish out what I need to do on my parentheses. And next I can apply my, and next I can work on my exponent. So taking 3 and multiplying it by 28. And I can apply that exponent to 1.03. So now what I have to do is I need to divide both sides by 11.97641607 in order to get P. Because that's going to cancel out on the right. And then on the left, I'll see that it's 14,999.99991. But again, this is money. This is how much do you have to deposit initially. So let's round to the nearest cent and we'll get $15,000. So 9% is, wow, I would like to know where they're banking. That's a great rate. So if you were to deposit $15,000 at 9% and compound it every 4 months, in 28 years, you would have $179,646.24.